Hello, Flat Earth researchers, debaters and debunkers. The belief or idea that we live on a globe is passed off as something that has been proven with science and the scientific method. So let's have a look at the scientific method that we have here and see how really it is flawed and how people with an agenda or presuppositions in the so-called scientific community can use this method and say they have followed this method to bring about the belief that something as ridiculous as the idea that we are on a spinning globe in the vacuum of space is somehow backed by science and methods that have adhered to the scientific method. So it's very straightforward, really. We have this here, make an observation at the top. So of course, most of the globe belief is based on making observations and interpreting those observations. For example, looking at the sun or the moon, the stars and the wandering stars or planets, and then making this connection to the Earth and assuming that the Earth is another planet or part of this planetary system or solar system, the heliocentric model, basically. So we have these observations. Of course, another common observation is the idea that ships disappear from the bottom up at the horizon. This is something that we're taught early on as one of those things that people used to believe in the olden days when they believed the Earth was flat, believing that ships would sail off the edge if they got too far. Which, to be honest, is as ridiculous as believing that the horizon is a curve. So there are these observations. There are also lunar eclipses, which are... So these are pretty much the three standard observations that have been made and associated with the belief that this proves we live on a globe. We have the sun, moon and stars, the luminaries, and assuming that the Earth is one of them, we have ships disappearing from the bottom up at the horizon and lunar eclipses. These are three fundamental so-called proofs that we live on a globe. Now, observations, of course, are governed by perspective, and of course we can make observations and we can make calculations from those observations. We can make very accurate calculations when it comes to things like surveying. We can estimate and quite accurately judge the size of something tangible on the Earth, its height above the ground or its distance, etc., because we have something to compare it with. We have this database of information of the sizes of most things. We know the approximate size of a barn, for example, or a car, or a water tower, whatever it might be. But when it comes to the sun, moon and stars, we really do not have anything to compare them to, and these are what you could say are intangible objects in the sky that we really cannot truly judge the distance and size of. But of course we can make very accurate observations and measurements and predictions as to when and where luminaries will appear. So yes, we can make observations and they often can be very predictable, and we can also see that something falls to the Earth. That's an observation. You know, Newton apparently observed an apple falling from a tree and drew many conclusions from the apple falling. So just briefly, for ships going over a curve at the horizon, this is an observation that we can make when we are low to the surface, and it is governed by many things, mainly perspective, but also other elements such as the weather, refraction, diffraction, the way light behaves, bearing in mind that everything we see is reflected light. So everything that comes into our eyes comes in at an angle of incidence relative to our position to it and how we can see it. So basically, when we are low to the surface, yes, ships will appear to be cut off by the surface. But if we get slightly higher up, then that doesn't happen. We see ships reach the horizon and we see them go off into the distance on top of the horizon. And at that point, they do not get cut off from the bottom up. Of course, as ships get further out into deeper waters, you've got waves and other elements that will affect the observation. So of course, this would mean that the bottom of a ship would be obscured by waves between us and the ship. And of course, the further out you can see, we do not see the choppiness or the size of those waves that might be obscuring the hull of a ship. But this is an observation that anyone can make, so there's no denying that ships do appear to disappear from the bottom up when we observe them going off into the distance when we are very low to the surface. The lower to the surface we get, the quicker we see that cutoff. But this is simply due to the fact that observations are governed by perspective, and the surface that we see in front of us will rise up to our eye level, and then there is a point where everything gets cut off. So the ships that go beyond that cut-off point will get cut off. It doesn't matter how much you zoom in from there, you will not see something that is blocked by whatever's in front of us. So, okay, we make an observation. Yeah, luminaries, lunar eclipses, ships on the horizon, etc. And then we ask a question. Why is that happening, I suppose, is a good question. And this is the important part here. From these observations and those questions, so the question is, what is the shape of the Earth, basically? Or how do these observations govern the shape, dimensions, and size of the Earth? And we form a hypothesis that answers the question. So here is where a scientist, per se, can have an idea about what causes certain things to happen when they make an observation. So of course we've had this hypothesis that ships disappear from the bottom up at the horizon because the Earth is curved and it's curving away from us. Or there's a bulge of curvature in front of us. Again, this is something that's never really quite clear when it comes to discussing the ideas that we live on a globe, or the observations. What are we actually looking at? Are we looking into a bulge of curvature, or are we looking at a relatively flat surface that curves away from us? This is a question that doesn't have a solid answer in the scientific community, especially when you look at the illustrations that we are given. Sometimes we're looking into a bulge, sometimes we're on top of a sphere looking at a surface that's curving away from us. Anyway, we have these hypotheses. We can also talk about, for example, the idea that the Earth has a certain mass, and it is that mass that creates gravity, or creates an external force, giving objects that have mass in the medium of air weight. And so we have these ideas that are formed from these observations, and we can make a hypothesis that the Earth is going around the sun, and in order for that to happen and to give us day and night, the Earth must be a spinning sphere. And how do we stick to that spinning sphere, because we know that as far as real life physics goes, sticking to the outside of a sphere is impossible. So we have to have this force. So the hypothesis comes about based on the presupposition that we're on a globe going around the sun, that there is some kind of force that allows us to stick to the Earth, to be pulled down to the Earth. And of course, if you want to draw that, you can illustrate it as everything being pulled towards the center of a spherical mass. So here is that hypothesis that the Earth has a particular mass, and that it is falling through space, just as we see an object falling through the medium of air or a vacuum. And then we make a prediction based on the hypothesis. So anyone can predict that if you hold a solid object and let go of it, it will fall. So we can certainly predict that the object will fall, and we can hypothesize that the object is being pulled towards the center of this spherical mass of the Earth in order to support the original theory that we're on a ball going around the sun. So we make those predictions, and it can be predicted that the object that we drop will fall at a certain rate of speed or acceleration. And so then experiments are done to test this prediction. So they did things like drop cannonballs off the Leaning Tower of Pisa, or drop things in a vacuum chamber. And as predicted, objects will fall at a certain rate of acceleration, therefore appearing to confirm the predictions and the theories. So there's this prediction that things will fall at a certain rate when they are dropped. The tests are carried out. Lo and behold, things will fall at a particular rate of acceleration until they hit the ground, and then those results are analyzed. We see that it doesn't matter about the mass or the size of an object, a cannonball or a feather, what have you. In the right conditions, it will fall towards the Earth at approximately the same rate of acceleration. And so, voila, you have this idea that the hypothesis is correct. We have this hypothesis that the Earth's mass is creating this downward force on all the objects that have mass that are dropped, and we get predictable results from performing these experiments, and those results are widely published, and they very quickly become fact. Of course, the people doing these experiments are people in positions of influence in, for example, the Royal Society. So they, their word will be taken as gospel, and the results that are then published in the media are taken as a fact, and very quickly we have what appears to be a theory, an idea based on a whole bunch of presuppositions that has been proven with the scientific method, when really all we have is a bunch of presuppositions and ideas that appear to have been proven with predictable measurements. And this is why people often say that the heliocentric model has these predictive powers, and we can make predictions about when and where we will see luminaries, and that makes the heliocentric model a so-called fact, and the fact that we will drop something through the air and it will head towards the ground. This is all considered enough proof to confirm the theory or the hypothesis. Of course, on the other side here, we've got the hypothesis is incorrect, and then we can try again. So how do we, the thing is, how do we go about verifying this idea that the mass of the Earth is something that creates weight, creates gravity? Gravity just means weight anyway. Can we go out and weigh the Earth? No, we can't. Can we do anything to verify this idea that the Earth has a particular spherical mass, and that it is that spherical mass that is creating this downward acceleration or external force pulling or pushing things down towards the Earth, or the center of gravity, as it were? No, there is no way we can ever verify that. We cannot do that. So this becomes something that cannot ever be confirmed with a truly scientific method. Now, of course, people will say that a certain amount of deductive or inductive reasoning has been used to come up with the hypothesis and bring about these so-called proofs. Again, it comes back to the presupposition that we are going around the sun and that the Earth is another planet. And it all stems from that. And what is this? Is this real science, or is this just mathematical models based on observations? It is not real physics. For example, real physics, we can create gravity or weight with real physics if we take, for example, a cylinder, and we rotate that cylinder, and we are inside that cylinder, then we can be forced against the sides of that cylinder, centrifugal force, if you like, as that object is spun. Whatever's on the object will get pushed to the outside. So then, if we were standing on the walls of this, on the walls inside this spinning container, then we would have gravity. Weight is created by this spin. That's real physics. But when it comes to telling us that we actually have the same effect happening to us on the outside of a sphere, this is a total inversion. It is the total opposite of anything that is related to real physics. Yeah? So yes, we can create these forces and push things in certain directions with an external force, or by spinning something. But to have us put on the outside of a spinning globe and assume that the mass of the Earth is pulling us towards it while it's spinning and orbiting the sun really is ridiculous. It is anti-science. It's just not physics. Yet we are taught to believe that it is, because certain experiments and measurements have been done, certain predictions can be made, and those results are repeatable, and they appear, by using this scientific method, to have proven the hypothesis simply by having repeatable measurements and observations. So I hope that kind of puts things into perspective. It's something to consider and to use our discernment about or with when it comes to considering whether the idea or the belief that we live on a globe is or isn't science, and has that ever really been proven with a true following of the scientific method? I'd say it hasn't, and that's why this whole thing really is still up for debate, as it were, and proper scientific exploration. Thank you very much.